Assalamualaikum warahmatullahi wabarakatuh. So welcome back to the chapter linear programming, chapter 3 of the operation research linear programming. So in the previous video, we learned about the maximization problem or maximization model. So actually what I mentioned earlier, linear programming only have two model. So the first model is a maximization and second model is a minimization. Okay, so for the maximization, what we need to do, why we use a maximization? Because of the uh, profit. Okay, so the difference only the linear programming, which is the maximize Z. Okay, for this video actually we will see what is different between maximization and minimization, and also how to solve the problem of the minimization. Okay, so in the previous video actually solving the problem of the maximization. Alright, so now we go for the next model, which is minimization. Alright, so far any problem or any question on the minimization? Okay, if you have any problem, you have any question, you can ask me through the WhatsApp group, through or you can WhatsApp me. Alright, so now we go for the minimization model of the linear programming. Okay, so in the Munchies, this is the situation. In the Munchies Krill company, make a krill from the several ingredient. Okay, two of the ingredient is oat and rice. Okay, oat and rice provide vitamin A and vitamin B. Okay, so the company want to know how many ounces of the oat and rice should be included for each box of krill to meet the minimum requirement of the 48 mg of vitamin A, 10 mg of vitamin B. To meet minimum requirement of the 48 mg vitamin A and 10 mg of vitamin B. So where are the oat contribute 4 mg of vitamin A and 1 mg of vitamin B. Okay, so while rice contribute 12 mg of vitamin A and 2 mg of vitamin B. So an ounce of oat costs 5 cents. Okay, an ounce of rice costs 3 cents. So solve the problem by using graphical analysis. Okay, so this is the situation. So what the information we can get from this situation? Number one, oat and rice. So two ingredients, oat and rice. So oat is a S1, rice is a S2. Okay, so provide vitamin A and vitamin B. So what is a vitamin A and vitamin B? Vitamin A and vitamin B is the constraint. Okay, so the company want to know how many ounces of oat of rice required for each box to meet the minimum requirement. Alright, so that means this must be more than requirement, because this is the minimum requirement. 48 mg of vitamin A and 10 mg of vitamin B. So where oat contribute, S1 is oat contribute 4 mg of vitamin A and 1 mg of vitamin B. Rice contribute 12 mg of A and 2 mg of B. So the cost. Okay, so here is the cost. Previously, in the previous video, actually the profit, that's why we use a maximization. So here is the cost. Cost is a 5 cent of ounce, 5 cent of rice and 3 cent of the for the rice. Okay, then we need to solve the problem. So before we solve the problem, summarize the situation. Alright, so this is the summary. how we can summarize. So S1 is oat, S2 is a rice. Okay, the constraint are we only have a two constraint here. So number of constraint depend on the situation. So we see the first constraint is a vitamin A, second constraint is a vitamin B. Minimum requirement of the vitamin A 48, minimum requirement of the vitamin B is a 10. So based on this statement. Okay. So vitamin A for oat is a 4 and 1. 4 vitamin A, 1 vitamin B. For rice 12 and 2. The cost for the oat is a 5 cent. The cost of the rice is a 3 cent. Okay, this is the cost. This is how to differentiate between maximization and minimization. So this here is a cost. So when a cost, that means the problem is a minimization. Okay, so now for the first step, formulate a linear programming. So minimize. In the previous video is a maximize. Here is minimize z equal to 0.05 s1 plus 0.03 s2. How I get this one? From here, 0.01 s1 plus 0.03 s2. Okay, subject to. So subject to means what is the constraint? Constraint yang pertama, the first constraint is a 4s1 plus 12s2 must be more than or equal. Why more than or equal? Because here is the minimum requirement. Okay, so the second constraint is a 1s1 plus 2s2 must be more than or equal also, because this is the minimum requirement. Okay, because the statement is a minimum requirement. Okay, compare with the previous video for the previous situation, which is limitation of the resource. Here there are no limitation of the resource. Here the statement mentioned the minimum requirement. Okay, alright, so that's why here more than or equal. Okay, the third constraint is s1 and s2 must be more or equal than 1. Again, this is because of the first quadrant. Okay, we just focus in the first quadrant. Same thing like our maximization problem, which is s1 and s2. Okay, alright, so now we have one constraint, we have two constraints. First constraint and second constraint. So now solve the problem by using graphical analysis. Okay, so how to solve? The same thing like maximization. We go for the first one, 4s1 plus 12s2. Okay, 4s1 plus 12s2 come from here. Okay, so how to solve the problem? Number one, we assume s2 is 0. So when we assume s2 is 0, so that means 4s1 plus 4s1 equal to 48. So s1 is a 12. So second one, we assume s1 is a 0. So when we are assume s1 is a 0, that means 12s2 equal to 48. So s2 equal to 4. So the first point is a 12 and 4. So that means s1 12, s2 4. Okay. Okay. So now we go for the second constraint. So which is s1 and s1 plus 2s2 equal to more than 10. So again the same step. So assume s2 is 0, S2 is 0, so that means S1 is a 10. Okay, second step, assume S1 is a 0, so S2 is a 5 because of S2 equal to 10 minus 2. Okay, 10 divided by 2. Okay, so the second point is a 10 and 5. Okay, so now we plot the graph. So maximum number here is 12, 4, 10, 5. So we can use maximum number of the graph is 12 and 12. S1 is 12, S2 is 12. Alright, so we only have a two constraint here. Two constraint only. That means in our graph we only have a two line. Okay, so the first line is a 12 and 4. 4S1 plus 12F2 more than 48. Okay, so second line is a S1 10 and 5. Am I right? 10 and 5. This one, 10 and 5. So 10, so second line is 10 and 5. 1 S1 plus 2 S2 more than 10. Alright, so this situation actually more than, not a less than. So if we draw the line, if less than, that means the shaded area is here. Okay, if let's say the less than, if this area is a 4 more than. Okay, since this problem is a more than, so where is the shaded area? So for this line actually start from here. Am I right? And this line is start from here. Where is the step area? Where is the visible area? Visible area is here. For the visible area, that means the shaded area for the both line. Okay, so when the shaded area, the visible area is here, that means we have a three possible point. 1, 2, and 3. So how to solve the problem? To solve the problem, we assume Z any number from the objective. So the objective is a minimization Z, minimum Z 0.05 S1 plus 0.03 S2. So let's say now we assume, this is, you can assume any number actually. So let's say we assume Z 0.15, insert into the formula of the objective, we can get 0.15 equal to 0.05 plus 0.03 S1 and S2. So same step, assume S2 0, assume S1 0. So we get a number of 3 and 5. So plot the graph, plot the line in the 3 and 5. 3 and 5, and draw the 90-degree line. Okay, draw the 90-degree line and move forward into the objective and onto the objective line. So for the maximization actually we need to find the last point of the possible point. Possible point here 1, 2, 3. For the maximization is a last point, but for the minimization is the first point we found when we move our line. Alright, so since this is the first point when we move our line, our blue line. Okay, so that means here is the optimum point. Optimum point is a 0, 5. That means S1 0, S2 5. Okay, and insert into the formula of objective 0 and 5. That means the cost, the minimization of the minimization of X is 15 cents. Insert the formula into S1 and S2, 0 and 5. That means our cost to produce the product is minimized cost is only 15 cents per unit. Okay, alright, so understand. If you have any problem, you can WhatsApp me, you can WhatsApp the group. Alright, so This is the chapter 3 linear programming. Thank you very much. See you again on the next chapter. Assalamualaikum warahmatullahi wabarakatuh.